Signum and greatest integer function. In this module, you will learn about the graphs, domain and range of the signum and the greatest integer function. Recall that a function is a relation in which each input is related to exactly one output. Suppose we have a function f that maps a set x to a set y. The set of all inputs of a function is the domain of the function. The set of all possible outputs of a function is the codomain of the function. The set of actual outputs of a function is the range of the function. If x is the input to the function f, then f of x represents the corresponding output. Now let's learn about a signum function. Look at a function from a set of real numbers to a set of real numbers defined by f of x equals the modulus of x upon x if x is not equal to 0, and f of x equals 0 if x equals 0. When x is greater than 0, the modulus of x upon x equals x upon x, which equals 1. When x is smaller than 0, the modulus of x upon x equals minus x upon x, which equals minus 1. So, the other way to define this function is f of x equals 1 if x is greater than 0, f of x equals 0 if x is 0, f of x equals minus 1 if x is smaller than 0. Such a function is called a signum function. Now let's plot the graph of a signum function. For all x greater than 0, f of x equals 1. So we draw a horizontal line parallel to the x-axis so that it lies to the right of 1 on the y-axis. This small circle on 1 indicates that it is not included. For x equal to 0, f of x equals 0. So mark a point at the origin. For all x smaller than 0, f of x equals minus 1. So we draw a horizontal line parallel to the x-axis so that it lies to the left of minus 1 on the y-axis. This small circle on minus 1 indicates that it is not included. The graph of the signum function shows that the domain of the function is a set of real numbers and the range is a set of minus 1, 0, 1. Now let's look at this function. It is called a greatest integer function. The function is named so because x assumes the value of the greatest integer, which is less than or equal to x. Let's take some real values of x and see the output of the function. If x is 0.6, then the greatest integer, which is less than or equal to 0.6, is 0. If x is minus 0.5, then the greatest integer, which is less than or equal to minus 0.5, is minus 1. Similarly, for x equal to 1.99, the greatest integer, which is less than or equal to 1.99, is 1. For x equal to 2, the greatest integer, which is less than or equal to 2, is 2 itself. For x equal to 2.7, the greatest integer, which is less than or equal to 2.7, is 2. Observe that this function rounds down every decimal value of x to the nearest integer. Now let's plot the graph of the greatest integer function. For x greater than equal to 0 and less than 1, the output of the function is 0. This small circle indicates that x equal to 1 is not included. For x greater than or equal to 1 and less than 2, the output of the function is 1. This small circle indicates that x equal to 2 is not included. For x greater than or equal to minus 1 and less than 0, the output of the function is minus 1. This small circle indicates x equal to 0 is not included. Repeating the procedure for other values of x, we get this graph. The graph shows that the domain of the function is a set of real numbers. The range of the function is a set of integers. In this module, you have learnt the following.